Here the question is the maximum phase shift that can be provided by a lead compensator with transfer function g of s is equal to 1 plus 6s divided by 1 plus 2s. This is the question. The options are first option 15 degree, second option for 30 degree, third option 45 degree, and last option is 60 degree. So before doing this problem, you have to learn what is a compensator. So compensator is a component in a control system that is used to regulate another system. Usually it is done by conditioning the input or output to that system. So there are three types of compensators: lag compensator, lead compensator, and lag lead compensator. These are the three types of compensators that are used in the control system to regulate the system. Okay, so here you have to find out what are the maximum phase shift that can be provided by using a lead compensator whose transfer function is given. Okay, then first you have to write this g of s is equal to 1 plus 6s divided by 1 plus 2s. For finding the phase shift, we have to replace s is equal to j omega. So g of j omega is equal to 1 plus 6 j omega divided by 1 plus 2 j omega. We all know that for finding the phase, the equation is phi is equal to tan inverse numerator. Okay, numerator. Numerator means tan inverse imaginary part by real part. So imaginary part means 6 omega by real part equal to 1. Minus term for denominator, plus for numerator and minus for denominator. Tan inverse 6 omega by 1. That means tan inverse imaginary part by real part divided. Okay. Now, for finding the phase shift, you have to differentiate phi with respect to omega and equate this equation to 0. That is, d phi by d omega is equal to 0. Okay, so find d phi by d omega. Okay, we know that d by dx of tan inverse x is equal to 1 by 1 plus x square. Here x is equal to omega or 6 omega. Okay, so by using this equation, tan inverse d by d omega of tan inverse 6 omega is equal to 6 omega divided by 1 plus 36 omega square minus, similarly, tan inverse d by d omega of tan inverse 2 omega is equal to 2 omega divided by 1 plus 4 omega square is equal to 0. Okay. So you have to solve this equation. That is 6 omega by 1 plus 36 omega square minus 2 omega divided by 1 plus 4 omega square is equal to 0. That is 6 omega by 1 plus 36 omega square is equal to 2 omega divided by 1 plus 4 omega square. You have to solve this. This side and this side omega will be cancelled, and 2 6 will be cancelled by 3. So 3 by 1 plus 36 omega square is equal to 1 by 1 plus 4 omega square. Cross multiply this term. That is 3 into 1 plus 4 omega square is equal to 1 plus 36 omega square. On solving this, we have to find out the value of omega. That is 3 plus 12 omega square is equal to 1 plus 36 omega square. That is 3 minus 1 is equal to 36 omega square minus 12 omega square. That is 2 is equal to 24 omega square. That is omega square is equal to 2 by 24, which is equal to 1 by 12. Or omega is equal to 1 by root 12 is equal to 1 by 2 root 3. This is the value of omega. But we have to find out the phase shift or phi. Okay, so in order to find out the value of phase phi, you have to substitute the value of omega in this equation. So phi is equal to tan inverse 6 into 1 by 2 root 3 minus tan inverse 2 into 1 by 2 root 3. That is 2, 6 will be cancelled, 3. Root 3, 3 divided by root 3 means that is tan inverse root 3. 2, 2 cancelled. So phi is equal to tan inverse root 3 minus tan inverse 1 by root 3. Tan inverse root 3 means 60 degree minus tan inverse 1 by root 3 is equal to 30 degree. That is 60 minus 30 is equal to 30 degree will be the correct answer. That is option B. 30 degree is the correct answer. Okay. Next question will be discussed in the next video.